Welcome students for today's class. Today we will do lesson 5 of electrostatic potential and capacitance. In the previous lesson, we discussed the potential energy of a charge and potential energy of a system of 2 charges, potential energy of a system of 3 charges. Today, we will discuss potential energy of a charge in an external electric field and potential energy of a system of 2-point charges in an external electric field. Okay. So here we are applying an external field. There is an external electric field. When a charge is placed, bringing in an external field, the work done to bring the charge from infinity to this external field is, you know the equation for work done, W is equal to V into Q. V is the potential due to the external field. Okay. So here there is an external field. This is an external field, electric field. I am bringing a charge Q from infinity to this point P. And you know, because of this field, there is a potential. That potential I am taking as VR. Potential at this point is taken as R. So potential energy is the work done to bring a charge Q from infinity to this point. So what will be the potential energy of the charge? Potential energy of the charge is, we can say W. Potential energy we usually denote by the letter U. W is equal to Q into VR. What is VR? Potential at that point due to the electric field. Now we will discuss potential energy of a system of 2-point charges in an external field. Potential energy of a system of 2-point charges in an external electric field. Okay. So let me draw the diagram. We can draw the diagram. So we draw a coordinate system, X, Y axis. Okay. This is one axis, Y axis. And there is an external field here. Field, external field, electric field. Now I am bringing a charge Q1 from infinity to this point. So here potential is V into R, R1. R1 is the position coordinate. This is R1. Position of the charge from the origin. Position vector of the charge from the origin is Q1. Position vector of the charge Q1 from the origin is R1. So potential is R1, VR1. So work done to bring the charge Q1 from infinity to this point is V1 into Q1. You know the equation. Work done is charge into potential. Work done to bring the charge Q1 from infinity to the point. So I am taking this point as capital A to the point A. Position vector of point A is R1. Is, you know, Q1 into VR1. What is VR1? VR1 is the potential at the point A. Okay, that potential is due to the external field. Similarly, I am bringing a charge Q2 from infinity to this point B. This point B position vector is R2. So here potential due to the external field is VR2. R2 is within bracket. Potential depend on R only, position. Okay. So what will be the work done? Same equation we can use. Work done to bring the charge Q2 from infinity to the point B. The position vector of the point B is R2. Is, what is the equation? You know the equation, Q2 into VR2. Q2 into VR2. VR2 is the potential at the point B due to the external field. Q into VR2. Okay. Now you know these two charges interact also. So at the point P, there is another potential due to the charge A1, Q1. So we have to find out the energy due to their mutual interaction. Potential energy due to the mutual interaction also. That energy, you know, that work done we are taking as W12. So work done due to the mutual interaction, work done against the mutual interaction, their mutual interaction, I am taking as W12. That you know, we learned already. What is the equation? Potential energy between two point charges, 1 by 4 pi epsilon 0 Q1 Q2 by R12. What is R12? R12 is the distance between A and B. Okay. Now, total potential energy of the system is, we have to add these three terms. Therefore, the potential energy of the system of charges. System of 2-point charges. In the external field. Is, you have to add the three terms. I am writing potential energy as U. So what are the three terms? Q1 into VR1 plus Q2 into VR2 plus 1 by 4 pi epsilon 0 Q1 Q2 by R12. This is the equation for the potential energy of a system of 2-point charges in an external electric field. What are V1 and VR1 and V2 here? VR1 is the potential at the point A, that is at a whose position vector is R1 because of the external field. VR2 is the potential at the point P because of the external field. So this is the equation for the potential energy of a system of 2-point charges in an external field. See, this is a small derivation and this is very important for the board examination point of view. Okay. Now we can discuss a question, a numerical related to this. I will give you a question from the textbook. Actually, the textbook example I will give you, we can solve it. I will give you the question first. This is the example 2.5 in your from the cbse NCERT textbook. So read the question A. Determine the electrostatic potential energy of a system consisting of 2-point charges 7 microcoulomb and -2 microcoulomb with no external field placed at -9 centimeter 0, 0, 9 centimeter 0, 0 respectively. And we already learned the equation for the potential energy between 2-point charges in the absence of an external field. You know the equation. What is the equation? U equals 1 by 4 pi epsilon 0 Q1 Q2 by R12. Here Q1 is given 7 microcoulomb. Q2 -2 microcoulomb. So before doing the problems, first you write the given data. Okay. Then based on the given data, write down the relation connecting between them. Then substitute the values, solve it. These are the steps for doing the numericals. First, read the question, understand the question, write down the given data. Okay. Then think the relation connecting these given quantities, write down the formula, apply in that formula given quantities and solve it. These are the steps for solving the numericals. Okay. So here Q1 is given, Q2 is given. What is the distance between them? R12. The coordinate is given. For first step, charge coordinate is -9, x coordinate. Second one, x2 is 9 centimeters. So how will you find out the distance between them? X2 minus x1. That is 9 minus -9. You know, this is a distance formula. So 18 centimeter. Okay. This will be 18 into 10 raised to -2 in meter. Now just to put the value in the equation. So U is equal to 1 by 4 pi epsilon 0. Q1 is 7 into 10 raised to -6. Q2 -2 into 10 raised to -6 divided by 18 into 10 raised to -2. 1 by 4 pi epsilon 0 value, you must remember 9 into 10 raised to 9 into minus 14 into 10 raised to minus 12 divided by 18 into 10 raised to minus 2. You have to solve it. On solving, you will get the answer as minus 0.7 joule. Solve yourself, minus 0.7 joule. So this is the potential energy of the system of 2-point charges, given charges in the absence of external field. Okay. Now let us see the second question, B. How much work is required to separate the two charges infinitely away from each other? See, we define potential energy of a system of charge as the amount of work done to assemble the charges from infinite separation to the present configuration. That is how we define the potential energy of a system of charges. So the potential energy of system of two charges we found. Now you got minus 7 joule. Now you are moving away. So you have to do opposite work. So it will be minus of this work. So answer to the part B is work required to separate the two charges to infinite separation is just opposite. Sign you change. So B answer is work done to separate is negative of this previous one, negative of minus 0.7 joule. So you will get 0.7 joules. This is the work required to separate the charges from present configuration to the infinite separation. Now, what is the third question? Suppose that the same system of charges is now placed in an external field. Okay. E is given, external field is given. Okay, it is A into 1 by R square. A value given. What would be the electrostatic potential energy of the configuration B? So now we are keeping it in an external field. We learned the equation for the potential energy of a two system of charges in an external field. We know the equation. What is the equation? So C part. Equation, you know. What is the equation? U equals V into R1 into Q1 plus Q2 into V R2 plus 1 by 4 pi epsilon 0 Q1 Q2 by R12. Here electric field is given. What is electric field? E equals A into 1 by R square. You know the equation for potential difference. Potential difference V is, you learned in the previous chapter also. E into R, electric field into distance. So we can write A into 1 by R square into R. So what is the potential difference equation? A by R. Okay. Now you put this in the equation. U equals Q1 into VR1, we write E R1 into R1. Okay. That small E after E, that small R1 is in bracket, that is not multiplied. So E into R1 plus Q2 into E R2 into R2 plus 1 by 4 pi epsilon 0 Q1 Q2 by R12 you already calculated. That you calculated as minus 0.7 joule. Minus 0.7 joule. That is the potential energy due to their mutual interaction. Okay, this you know. First part of this question. In the A part, we have calculated that. Now, Q1, you know, what is its value of charge? Q1 was, what was the charge for first one charge? Q1 was 7 microcoulomb. Q2 is minus 2 microcoulomb. So you can write here 7 into 10 raised to minus 6. Electric field E into R. Actually, we have E into R1 is the potential we found out here. That is E by R1, right? Plus Q2 minus 2 into 10 raised to minus 6. See, this E into R2, this one is A by R only, right? So A by R2, right? Minus 0.7 joule. 7 unit you write later. So 7 into 10 raised to minus 6. Value of A is given. What is the value of A given? In the question it is given as A as 9 into 10 raised to 5. So substitute the value 9 into 10 raised to 5 divided by R1. R1 is the position coordinate. It was 9 centimeter, right? 9 into 10 raised to minus 2 minus 2 into 10 raised to minus 6 into 9 into 10 raised to 5 by 9 into 10 raised to minus 2 minus 0.7. Okay, you simplify this. On simplification, what we will get? On simplification, we will get first term as 70. On calculation, you will get first term as 70. Second term minus 20. Third term is minus 0.7. So the answer will be 43.9 joule. 49.3 joule. So this is how we calculate the potential energy of a system of 2-point charges in an external field. Okay, dear children. Here we are ending today's class. Children, go through it. Everyday practice regularly. Physics is not a very tough subject. You feel it is tough if you practice regularly every day. If you understand the concepts, practice regularly, it will be very easy for you. If you don't practice, if you don't learn regularly, it will be a tough subject for you. Okay, children? So learn it regularly, okay? So that it will be easy for you. Goodbye, children. We will meet you tomorrow. Thank you for watching. Share it, subscribe it. Thank you again.